thing about the binomial or the binom of n and k is that they do have symmetry. What does that mean? It means that at this point we are going to work smarter, not harder. The binom of n and k, the number of times that I can choose k items out of n, is the binom of n and n minus k. Again, is equal to the number of choosing n minus k items out of n. Or at some point we can say choosing k items to take is the same as choosing n minus k items to leave behind. Imagine that you would like to choose 2 items to take, 2 out of 10. It is going to be as the same as choosing 8 items to leave behind. How many times you can leave 8 items? At this point, it seems that it would be a little bit simpler to find that because we do have 8 items, right? So let's talk about the calculation wise. If I consider it as 10 and 2, imagine that if I had 10 and 8, it would be 10 factorial divided by 2 factorial times 10 minus 8. 10 minus 2 would be 8 factorial. Yes, I know we had a way for that. Actually, we had this way in order to simplify it. But we do have another way. We know a fact, right? So what would happen if I find the 10 and 2? 10 and 2 would be a little bit simpler because I do have 10 factorial divided by what? Divided by 2 factorial times 8 factorial. By the way, at this point, I did a mistake. It was 10 factorial divided by 8 factorials times 2 factorials, right? So at this point, when I do have this number, it's still, they're somehow the same. And maybe some of you would say that, what did you do? It's not that kind of magical thing. The only thing you did that just changed the position of 8 and 2. Still, we can simplify that, right? So, and I'm telling you, this kind of way is going to help you to do what? Imagine that, let's go back to the main question we had, x plus 1 to the power of 5. On one point, I had the 0 out of 5, again 1, simple. 1 out of 5, still 5, again simple. But for 2 out of 5, we find it a little bit challenging. Just a little, not that much, a little bit challenging. But imagine that by finding 2 out of 5, you also do have another answer. And maybe you would ask why. And you would ask how. You remember that 2 out of 5 is actually equals to 3 out of 5, right? 2 plus 3 is equals to 5, right? Just as the same as this kind of formula we had. So you would say that that's interesting. Keep going. It means that if I do have 2 out of 5, I already found the 3 out of 5. If I do have 1 out of 5, I already found the 4 out of 5. If I do have 0 out of 5, I already found the 5 out of 5. You see, the dots are getting connected, guys, right now. Out of that main question, we had to take so much time over that. We are reaching to the level to use the formulas. Not only using formulas, we use some concept related to that. It means that instead of finding all of those coefficients, at that point we had 6. Imagine that we do have 20 coefficients. You only have to find the 10 coefficients. And right now, you're just reducing your work by 50%. That's a huge number. Maybe right now you don't see it, but when you do have higher numbers, when you have bigger numbers, you actually are gonna sense it. That's why we just talked about this pattern. We just talked about this part that is going to be so useful in order to reduce your number of mistakes and reduce the time that you have for your question itself. So again, let's go back to our main questions. The main question was x plus 1 to the power of 5, but at this point, we do have x plus 2 to the power of 5. So one thing that would change over here is that my a is x, that's okay, but my b is not 1 anymore. My b is 2. So on the last question, when b was 1, you didn't care what power you had. You had the power of 0, you had the power of 1, power of 2, power of 9, power of anything would be 1. But right now, you have to be careful. So at this point, again, based on the binomial one or based on the Pascal's triangle, I do have this 1, 5, 10, 5, 1. First term is x, second term is 2. This is something that I'm telling you for all of your courses, for all of the question. First of all, try to understand what the question asked. Not all the time question is going to be all numbers. Questions are going to be real world applications. The very first thing that you have to do is to write down all of your knowns. This is something that I call my students all the time. Try to write down all of the knowns at the beginning, then try to ask yourself this question. What am I actually looking for? What are the ways that I know that I can reach to the thing that I want faster and with the less number of possibilities that I can have problems? Try to answer these questions, try to write them down. That will be so helpful to you, because there's always a time that you can check your answer and then check your knowns and check your questions, that because the questions could be so long. So this is going to be so helpful in order to not get you lost in that specific question itself. Try to keep it in your mind. So I know everything, and right now the final part or the question is that how I can simplify this one. I probably know something is related to sigma binomial of n and k. The first term, what was it? X to the power of n minus k, 2 to the power of k, which I know k equals to 0 to 5. It would start from 0 to 5. Let's do it. The binomial is something I know. I already found it. Let's forget about that. Let's put it aside. This is important. X to the power of n minus k, let's start from beginning, why k is equals to 0, right? X to the power 5, 2 to k to the power 0 is going to be 1. Simple, right? But next part is going to be important. X to the power 4, which I already knew, 2 to the power 1. It's getting interesting because we don't have 1 anymore. We do have 2 to the power 1. Cool? Then x to the power 3, 2 to the power 2, 4. X to the 2 to the power 3, 8. X to the power 1, 2 to the power 4 is going to be 16. X to the power 0 to the power 5. Not only I do have those numbers, but I also have to consider all of the coefficients at the end. And if I would like to simplify it more, I have to multiply the coefficients by each number. Coefficients, each number. Coefficient, each number. Do it till the end. And finally, I do have this one as my answer. X to the power 5, 10x to the power 4, 40x to the power 3, 80x to the power 2, 80x plus 32. You just saw that we had a question, and instead of just writing down x plus 2 5 times multiplied by itself, having all of those problems, all of those calculations, and we have to write down the whole page, we just did everything maybe in 2 or 3 some kind of rows. That was everything. We know about binomial. We know something about inside the binomial. 2 out of 5 is actually 3 out of 5. We know that all of the coefficients right there, and we are going to put them in one side. Then we know a formula. We are going to use that x to the power of n minus k times 2 to the power of k. Write it down step by step. Then we are going to apply all of those numbers, and at the end we are going to simplify everything as much as possible. This is how we just converted a 5 minutes question to 10-second or maybe 20 seconds question. So let's see another one. So at this point, it's going to be a little bit challenging. Why? Because of two things. My a is not x anymore. It means that while I'm powering this guy, I have to also take care of for example, 2x to the power 3 is going to be 2 to the power 3, x to the power 3, you know, this is a rule, is going to be 8x3. This is something that I have to take care of. Then another thing that I have is negative 3, guys. This is very important because so far, we had everything that was positive, but right now I do have negative. Maybe some of you would ask, okay, how this negative is going to be problematic? Because we know negative 3 to the power of 1 is negative 3. Negative 3 to the power 2 is positive 9. Negative 3 to the power 3 is negative 27. This negative guy is going to be problematic because it's going to be there on odd numbers of power. On even number of powers, you have the positive. You have to be very careful. Again, try to write down the knowns. So first of all, I'm looking for 4. Based on binomial, or maybe some of you just memorize the Pascal's triangle, we have 1, 4, 6, 4, 1. These are the coefficients, simple. The very first term is 2x. So the second term is negative 3. Let's go to the work. K equals to 0, the very first row. I do have my coefficients, which I can keep it there or I can just add it afterward, doesn't matter. Is 2x to the power 4 times negative 3 to the power 0. This guy is 1 because we know any number to the power 0 is just 1. 2x to the power 4, it is important. It's going to be 2 to the power 4, which is 16, times x to the power 4. So finally, I do have 16x to the power 4, while I also consider the 1. Next step, 4. Where did I get the 4? I got the 4 from the Pascal's triangle. 2x to the power 3. As I just told you, this guy is going to be 8x to the power 3. So this guy is going to be there. In the meantime, I also do have negative 3 to the power 1. So this is negative 3. This is 4. I had it from before. So I do have negative 96x3. Do this one for the next one, negative 216. And finally, you have 81. And you just have the answer that you like. As simple as that. So let's see some kind of real world application. mostly talking about that binomial effect, the number of choosing. Imagine that I do have a case. I do have 12 members. How many different four-person committees can be formed over here? This is a simple question, right? It is exactly a binomial of 12 and 4. We know a formula. N factorial divided by k factorial multiplied by 8 factorial. Cool? So we can solve it right now. Actually, I can write down the 12 factorial as what? As something like this. 12 times 11 times 10 times 9 times 8 factorial. On the other hand, or on some kind of denominator, I had 4 factorials times 8 factorial. These two can cancel each other. That's why we do have this one on the top. We do have 4 factorial, which is going to 24. And finally, you can find the number of possibilities. You see how big this number is? Imagine that you would like to do that by yourself. You have to choose the committee of 4 people 495 times if we consider the fact that you're not going to have any problem out of 12. This is going to be huge, especially in your working area, when you would say that, okay, I do have 12 people, how many committees that I can have out of 4 people? While I know this kind of fact that it doesn't matter if I do have Alex first, then Annabelle, or I do have Annabelle first and then Alex. Cool, this is something. So let's see another cool application of this one. I believe you heard about it thousands of times, but you do imagine you have a coin. And this coin has 2 parts. It either has heads or tails. And the question is that what is the probability? By the way, probability is a concept. It's not related to algebra. It's part of mathematics. Probably I'm going to have another kind of chapter-wise or some kind of playlist related to that. I'm not sure yet. But the probability means that how many times you can choose something that you like out of all of the possibilities. It's going to give you a number between 0 and 1. For instance, when we are saying that there is a 75% of chance that today we do have rain, it means that out of a whole day, there is 75% of the chance, or somehow 75% of probability that we do have rain today. The 25% is not rain. So it means that the time of the day that we don't have a rain is just 25%. And maybe the time of the rain that we do have is 75%. So 75% plus 25% is 100% is the whole thing. So this is very maybe simple, intuitive, and not that kind of clear maybe right now because I didn't have a very good example in my mind. But imagine that we do have a scenario. You do have some kind of different coins and you have some kind of 6 fair coins. By the way, what is fair coin? Fair coin means that the probability of having the heads and tails are the same. It means that there's a 50% of chance that you have tails and 50% of chance that you have heads. Some of you would ask, is there any coin that is not fair? Yes, we can have it. We can change the material inside the coin and make the mass of the part that we would like to increase its probability more in order to make sure that we are going to have that part or we are going to have that specific thing in the higher probability or higher chance. For instance, 70% to 30%. It means that 70%, or I can say from 10 times, it's average, by the way. Or maybe sometimes you would say that I did it 10 times and all of 10 times it would be heads. No, we're talking about average. Out of 10 times, if you flip the coin, the probability of having your heads is 7 and your tails is 3. But right now it's 50-50. 5 times heads, 5 times would be the tails itself. So the question is simple. The question is asking how many times out of 6 fair coins you are going to exactly have 2 heads. As I just told you, probability is diffraction. On the top is the number of times that you would like to have something. On the bottom is all of the chances, is everything that could happen. So let me just explain it to you right now what is going on with numbers. So at this point, the favorable outcomes, or the one that we need, or something that comes on the top, is the number of heads, or 2 heads. By the way, 2 heads could be anywhere. It could be here and here, doesn't matter. 2 heads. It means that I'm trying to choosing a team of 2 out of 6 people. Again, still the same. The concept is the same. So at this point, I'm saying that it's going to be 2 out of 6. or it's something that we just write it down as a binomial or binomial of 6 and 2. So we know a formula for that, right? 6 factorial divided by 4 factorial times 2 factorial is going to be 15 base. There are 15 times out of 100, or for example, out of 100, or out of all the possibilities, not 100. 100 is not the right answer. Out of all of the possibilities, there are 15 ways that I can have 2 heads exactly, without considering the fact that where is their location. Another thing that we have to know is about total outcomes. If we do have 6 flips and we know that each of them they have 2 possibilities, there is a formula for that. We can have 64 of total outcomes. How we got that? Imagine that I do have something like this. By the way, this is going to be the placeholder that each is some kind of each coin is going to be there. Multiply by next one, multiply next one, next one. It means that I'm going to multiply each possibility 6 times by itself. How by itself? Because how many times you have chance to have tails or not tail and end? Tail or heads at the first one? 2. Either is going to be head or tail, right? This is going to be for the first one. How many times you have to how many chances do you have for the next row? 2. Next 2, it would be 2 to the power 6. This means that there are 64 total outcomes, without respect to the fact that maybe some of them would be heads. The heads could be 6 times. We don't care. So far we had 2 numbers: 15 as my outcome, the one that I would like; 64 as total outcome. Finding the probability is going to be the favorable one on the top of total possible. It's going to be 15 divided by 64, and that's why we use the binomial over here. So let me talk about some of the mistakes that maybe you have, and it would be better to completely avoid it, right? Not would be better, it is recommended to avoid it. So the very first thing is about the binomial of n and k has a formula, and it's not n divided by k. Be very careful about that. This is very common. Another thing would be about the forgetting symmetry. It means that instead of calculating, you can calculate the 10 and 8, or 10 and a binomial of 10 and 8, instead of 10 and 2. Because since the 10 and 2 is something that you have to find at the beginning, you already know about the 10 and 8. So you just losing your time, you're just wasting your time finding 10 and 8. So it doesn't make any sense. Try not to use that. Again, you can do it. I'm not saying you can't. It's not wrong, but it's time wasting. Calculation error. Expanding full factorials, 10 factorials instead of canceling. As I just told you, when you do have, for example, 10 factorial divided by 2 factorial times 8 factorial, instead of just finding 10 factorial, 10 times 9 times 8 times 7, or maybe some of you would say that I can easily find it on a calculator. I'm saying that yes, but there's always chances for having problems or for having mistakes. We are trying to reduce it as much as possible using our brain. Not all the time we do have the calculators, right? So instead of just writing it down as 10 times 9 times 8 factorial, and then we can cancel out this 2, and we do have 10 times 9 divided by 2, which is very simple. We're going to find the 10 factorials, and we have the 8 factorial, we have the 2 factorial, multiply all of these, 10 divided by that one, and maybe or maybe not we get the right answer. Another one would be about the sign errors. That's one of the questions I told you about. If you remember, 2x minus 3 to the power of 4. Remember, you do have negative 3. There is no 3. There is no positive 1 anymore. Be very careful when you have a negative number and you have odd powers or even powers, because it's going to have effect over your sign. Finally, power pattern errors. It means that sometimes you're going to mix it up with a to the power n minus k and b to the power k. So for this one, I do have a tip. In order to not have the fifth problem, try to write out the variable pattern first, then fill in the coefficient. This is something that I told you from the very beginning. Try to write down all of these, some kind of terms and powers at the beginning, then try to add or put all of those coefficients beside, because we don't want to have any problem itself. So at this point, you can see some kind of questions that you have related to this chapter. So this chapter was started with a very simple question: x plus 1 to the power of 5. And the main question was that how I can simplify it. Obviously, we have different ways. The very first way is the normal and very common way to multiply x plus 1 5 times by itself, x plus 1 times x plus 1. Find a big number, then multiply by x plus 1. Again, bigger number, and do it 5 times. So obviously, you do have some problems. First of all, it is time consuming. Second of all, there's all the time, there are some chances that you have problem with. I gave you away, and I told you, or I promised you, that I can give you a solution that instead of just wasting 5 minutes or 10 minutes times, and maybe at the end you will get the right answer or maybe not, you have a 10-second answer that is going to guarantee you are going to have the right answer. That guarantee, first of all, started with the Pascal's triangle. I told you if you have the Pascal triangle, you are going to have your coefficients. Then I told you that instead of just remembering all of those numbers, I gave you away binomial. This binomial is going to be the number of times that you can choose k items out of n items. Then I told you that not only you can do that, but also you can find a way to make two things equal, or because of the symmetry that it has, the two things can be equal. The number of choosing 2 team members, or the team of 2 team members out of 10 guys, is as the same as the number of choosing or leaving 8 guys behind while still we do have 10 people. So by having that, we are reducing down the time of calculation by 50%. So by gathering all of those things, finding the answers for our problem, we found out that actually instead of just wasting so much time and maybe not we could find the right answer, we have the right answer with the least amount of time that we could dedicate for a question itself. I also talked about the 5 common mistakes. So by some kind of solving all of the questions that we had over here, the question that you can find it online, and maybe some kind of design it by yourself. And then the questions that I put over here, there are 4 questions, you can check, you can evaluate yourself. And if you have any question, by the way, just before finishing this video, don't forget to comment your answers in the video down below. And thank you for being here with me. Please don't forget to like, share, and comment. It would be so helpful to me. Have yourself a great day, night, whatever. See you around.